But if you have to decrease when you're getting, you know what? Let's re-answer your question even better. I love your question. Pick one of these other scenarios down here. Go ahead, Maddie.
On the one where it's 4.
4 and 1? Let's do it.
So would it just be 5, 4, 3, 2?
Hold that thought. Hold that thought. Hold that thought. There's something more to it. Now, what Maddie just asked is a very good question. No, hold that thought. We're going to answer it right now. Matt wants to analyze this. What's the chance of getting 4 of the non-Powerballs right and the Powerball? So they're telling us the odds are about 1 in 650 million or 650,000. That's better odds than this, isn't it?
Yeah.
That's better odds. Let's figure out where that number came from. Okay? Where the number came. Swing over here. Swing over here. Here we go. All right. So now we're going to go one more down. 4 and 1. All right. So what's the chance of Powerball and 4 out of 5 non-Powerballs? Okay? Powerball and 4 out of 5. We still have to pick 6 numbers. But now we're getting one wrong, and the one we're getting wrong is one of the non-Powerball numbers. That's the kicker. Okay? Here we go. Now we know overall, we still have this many tickets we're drawing from. We know that's the number of tickets we're drawing from. What we have to figure out next is how many of those tickets have the Powerball correct, 4 out of the 5 first numbers correct. Okay? Ben, help me out.
34 times the number,
59.
34 times 59.
Okay, let's go. Let's break this down. Let's break this down. There are 5 correct non-Powerball numbers. There are 5 correct non-Powerball numbers. Fair enough, right?
58.
But how many are non-correct?
57.
If there's 59 total, and 5 of them are winners, 54 are not winners, and you have to draw one of those, don't you? You have to pick one of the 54. So there are 5 correct non-power numbers. There are 54 incorrect non-Powerball numbers. And there's a correct Powerball. And there's a correct Powerball. So you have to account for all of those. This is like accounting for an area code, a local code, and a phone number. It's the same exact thing, except you have to break it up into the individual pieces. So, we've got 1, 2, 3, 4, 5, 6. Or put the Powerball at the end like we usually do. How many choices you got for that power? Janaea, go ahead.
What's the last thing? Correct.
There's one, oh, sorry. There's 1 correct Powerball. After I said it and didn't write it. 1 correct Powerball. Let's start with the Powerball.
58.
How many Powerballs? If you're going to get it, you only have 1 choice. That's the point. Anytime you see a plus red up there, that means you got the Powerball, which means you only have 1 shot at it. You've got to get that one correct. You've got to get that one correct. With me so far? With me so far? Okay. Now, let's decide right now, and it's not going to matter because of multiplication. Let's call these 4 numbers out here the ones that we got the correct Powerball numbers on, which means this guy right here is one we got the wrong Powerball number on. How many choices do we have for this guy right here? Does everybody see that? That's the 54. So this is the wrong Powerball number. This is the wrong Powerball number. You have to account for him.
Wrong non-Powerball.
Yes, wrong non. Thank you, Kurt. Non-Powerball. Thank you, Fred. Thank you. Yeah, that's the wrong. Yeah, Powerball's in the box. You have to account for that because you have to pick that number. You have to pick that one of those wrong numbers in order to have 4. Because you have, that's one way the ticket is a little bit of a liar. It doesn't show you the numbers you have to pick wrong. It only shows you the numbers you have to pick right. But you have to account for all of them because you have to pick 6. Is that fair? Mm-hmm. Okay, good. Now, Maggie, back to your point. Back to your point, right? You said it correctly. You said, okay, how many choices do I have here? You said it's 5. This is going to be 5 and 4 and 3 and 2. So you lost the 1, essentially, right? You lost the 1 because you're not getting that last one. So, now, everybody follow why that's 5, 4, 3, and 2?
The 120.
Because there's only 5 correct Powerball numbers, and you're starting to select from them. 5, 4, 3, 2. The problem is, we have to adjust those for order. We have to adjust because, remember, you can shade them in a bunch of different ways. How many different ways can you shade these 4 numbers in? I'll give you a hint. This is the math problem from your last project. This is the math problem. 4 characters to arrange in rows.
36.
Do you remember the answer from that one?
36.
M-A-T-H, M-T-H-A, M-A blah, 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 blah. It's 4 times 3 times 2 times 1. It's 4 times 3. There's 4 of them, right? There are 4 numbers, so you're shading 4 things in. There are that many, 24 I believe is the number. There's 24 different ways to shade it in. We don't have to do this correction for this guy or this guy. Why?
Because you just took out the order by.
Because there's only one of them.
Yeah.
There's no order when there's only one. If it feels better, you can put a number under it like that, like a 1 to 1. There's no order to concern ourselves with the Powerball because there's one Powerball, and there's no order to concern ourselves with the non-Powerball because there's only one wrong non-Powerball number. But here, these 4, when you grab the pencil to shade them in, there are 24 different ways to shade those 4 numbers in. And that's a problem because you can't count each of those. You can't count each of those as a unique ticket because when you hand the ticket back to the person, those numbers all look the same, regardless of how you ordered them, how you colored them in. Now watch this. This is kind of slick. This is why I like doing it this way. Notice how a lot of these cancel?
I was going to ask you if we could.
Yes, you can. What number's left when you're done?
The 5.
Only 5. The reason 5 is the one that's left behind is there are only 5 possible ways to do that. In other words, there are only 5 possible ways to miss the last correct number. Remember, you got 4 of the 5 non-Powerball numbers, correct? That means you missed one of them. There's only 5 ways for that to happen. You either missed the first one, or the second one, or the third one, or the fourth one, or the 5th one. And that's what it reduces to. It's only equal to 5. That's pretty slick, actually. That's pretty slick.
So tell me why, again, that I understand the 5, 3, 2.
Yes, for sure.
But where did the 4, 3, 2?
Here's the deal. Let me show you on the screen up here.
Okay.
Let me show you on the screen. I want to make sure you guys are buying that division. The division is what's throwing you for a loop, and understandably so. It's not the simplest idea. But I think I can convince you right now by actually playing the game a little bit. We're going to pull the ticket back up. All right, here we go. Here's the ticket. Let's make it bigger. Bigger. There we go. Here's our, make it even bigger.
Let's pick Oregon.
Let's pick.
You're playing Vermont.
Oh, it doesn't. It's okay. I totally get that. I'm going to be playing with these guys up here.
It's
not okay today.
That's not okay. I'm sorry. Hang on.
We're back to Janae's rules.
So,
Gave her
Sean,
too much
can I ask
power.
another question really quick?
Yeah, go ahead.
Do you times the 5 times the 54 times 1?
Yep. And that's your numerator.
All right.
Now watch this. Friends, pick 5 numbers that are the correct 5 non-Powerball numbers for me right now. Pick them for me right now. 17. Just make up 5 numbers. Doesn't matter to me.
3.
4, 3. Oh, what the hell? Let's make it easy. 1, 2, 3, 4, 5. Those are the correct ones. Okay? Now, you guys pick 4 of those numbers. Those are the ones I'm going to get right.
1, 2, 3, 4.
1, 2, 3, 4. Here's my pencil. I'm at the desk filling the Powerball ticket in. You ready? Here I go. Here's one way to do it. 1, 2, 3, 4. Right? That's one way to do it.
That's right.
What's another way to do it?
4, 3, 2.
4, 3, 2, 1. Another way to do it.
Oh, 2, 4, 3.
2, 1, 4, 3.
There you go.
Another way to do it. 2, 3, 4, 1. How many ways can I do that?
Many.
24. That's the number in the bottom there. The 4, 3, 2, 1 is the number of ways for me to color in so that I get the same exact 4 numbers shaded at the end. Does that make sense? So in other words, I'm going to get those 4 numbers shaded. 1, 2, 3, 4. Now some of you might be wondering, wait a minute, Rule, but everything divided off and you're left with 5. And you're left with 5. Where'd the 5 come from? Well, what assumption did I make right here?
The number 5 was wrong.
That I got the 5th one wrong. What if I get 4 wrong? Isn't that another option? And when I'm done, I'm going to have 1, 2, 3, and 5 shaded. That's still 4 out of the 5 correct ones. How about if I got 3 wrong? That's still 4 out of the 5 correct. Suppose I got 2 wrong. That's still 4 out of 5 correct, and last but not least, I could have gotten 1 wrong. Those are the 5 ways to get 4 out of those 5 numbers correct. Fair enough? And then the 54 is whatever's left of the remainder, I have to get 1 of those. That's the 54. Does that kind-of-ish make sense?
I'm confused on the 54 thing.
Don't worry. If there's 5 numbers that are correct, there's 59 total numbers here. If 5 are correct, then 54 are wrong.
But you don't have 5 correct. We're doing
You do.
4 correct.
Oh, you get 4 correct, but when the Powerball jackpot is drawn, there are 5 correct numbers. You are getting 4 of those 5.
Oh.
You see what I'm getting at there, Maddie?
Yeah.
Yeah, so Maddie, I love what you're saying. When you see the 5, I say 5 correct non-Powerball numbers, that means 5 were drawn. Your job is to match them. Is that fair?
Yeah.
But you only got 4 of them.
Okay.
You only got 4 of them. Is that decent? Great question, by the way.
Makes sense.
Good? So what's our numerator? It's 5 times 54. What's that, 270? 270? Let's do a quick calculation up here, friends. Let's do a quick calculation. Back to here. They claim the odds are, where are you? 1 in 648,000. Let's crank that real quick. 1 in 648,975.96. So the chance of winning by hitting 4 of the 5 non-Powerballs and the Powerball is 0.0000015. That's a chance. So it's 1.5 times 10 to the negative 6. Pretty crappy. Pretty crappy. We just calculated it as 270 over 175,223,510.
Same thing.
It's exactly the same thing. The only difference is they've written all their fractions with a 1 in the numerator. They've written all their fractions with 1 in the numerator. We're writing all our fractions with 175,223,510 in the denominator. But they're equivalent fractions. They have the same numerical value. They reduce, if you will. Scotty, go ahead.
270 is just a 5 times 54.
Yes, sir. It's just the numerator. Yeah. So what we're doing is we're throwing this back to the basics of probability, which is event space over sample space. Number of tickets that satisfy what they're telling us to satisfy divided by total number of tickets. That's all we're doing. That's all we're doing. Yep. I know it looks a little ridiculous because you got the big component pieces of it, but it breaks down to the same. Want to do another one?
No.
No.
Point out there's a 911.
No, what?
He's feeling like a crisis today.
Kurt's calling 911s a lot today. He knows it's not. Kathleen, go. What do you see? What do you see? You should go ahead. Be brave, my friend. Oh, you're looking back over to here? I'm sorry. You're looking back over here? You're on the screen. I'm sorry. Back. Sorry, a lot of flashing. I apologize. 911. Go ahead.
It's that one, third one, 6, 4.
It looks like those numbers are going down when they just got negative 6. Give it the next
Oh, wait a minute. It looks like.
negative 5.
Oh, so the next one maybe a -5. What Kathleen's noticing is that these are getting more likely. 10 to the negative 7 is smaller than 10 to the negative 6. So the probabilities are going up, which the hope of that makes sense. It's easier to get 4 right and 1 wrong than it is to get all 5 right.
And it's easier to just lose.
Of course it is. That's part of your take-home exam is to figure out the chance of just losing. That's part of your exam is to figure
I
out the
already
chance of
know.
Good.
I'm gonna lose.
I want you to quantify it for me though. Now,
It's like going, I'm pissed.
but notice too, Kathleen, I love what you said. Notice too that as the odds go up, what goes down?
The money.
How much they pay you for it, right? And that's the interesting part. The interesting part is what's the balance
I don't
between
want
how much
to
they're
win more
paying
now.
and how much. Well, let's start analyzing your take home. Ben, go ahead.
Well, it doesn't seem to be a pattern, though.
It's only a pattern in the numbers we're using to calculate the odds. You mean the pattern here or the pattern here?
The pattern between the percentage.
There's not really. There's a pattern in the overall game itself, which is what you guys are going to analyze in your take-home exam, is analyzing the entire average payout of the ticket. Go ahead, Matt.
What's the amount of money you win before the IRS comes in and takes whatever that
About
is?
half.
Okay.
Roughly half the
Yeah,
prize.
but I mean, how much do you actually have to win before they take half the money? Any amount?
Oh, that's a good question. I don't think,
They can't take it from 100.
I made it very simple. On your exam, to keep the tax code simple, I just said to adjust for taxes, make everything a half.
Okay.
Although I don't think they knock you for the 100 and the 10 and the 10,000. I think they knock you for the ones up here.
Yeah.
But that's where the lion's share of the payouts are coming from anyway.
Yeah.
So I just say take half all the prizes and call it. Like they're not docking you $2 on a $4 win.
Yeah.
Now realize too, I mean look at that, friends. Look at that. The chance of winning, just hitting the Powerball is 1 in 55.41. This is why you can't just buy all the tickets that have all the Powerballs on and expect to make money. I mean, you could do that. There are 35 possible Powerballs, right? So buy 35 tickets, each one of which has one of the Powerballs highlighted. So one has 1, one has 2, one has 3. You're going to guarantee make $4. Except you just guaranteed lost 35 to make 4. You see what I'm getting at there? That's the problem. Now what's interesting is you just saw a very interesting application. There are only 175,223,510 tickets. So all you've got to do, I think we've talked about this before, is buy them all. Then you're guaranteed to have the jackpot. We did talk about this, didn't we? And when the jackpot's more than $175 million, you've made more money. The only prohibitive factor is getting all those tickets. You have to start now for a drawing that's going to be held in 2,000 years, I think, to make sure that you get them all, right? That's the idea.
Did they calculate it was like 38 or 40 years?
Was it 40 years,
Yeah,
something like that?
it was
Right.
a lot.
So start now for a drawing in 40 years, if they even let you do that. And what I thought about too, this is kind of interesting. If you do that, not only do you have the Powerball win, you don't have it, but you also have 34 of these,
Oh,
don't you?
okay.
Remember, if you bought every ticket, you not only have the grand prize, but you also got $34 million in this because you bought all 34 of those tickets. You've also got $2.7 million here because you bought all 270 of these, right? Now, whether or not they let you slide with that, I'm not sure. But it's a moot point anyway because you'd have to actually purchase them all, which you can't do. So, you can't beat the system, is what I'm getting at here. And your take-home exam proves to you why you can't beat as soon as you put taxes into it. Cool? So, that's your take-home exam. That's it. You're analyzing Powerball. You're doing what we just did, but a couple more times.
Woohoo!
So, for Thursday, bring questions, because there's a quiz due Thursday as well.
Right.
If you guys need more time to work on it, feel free to bring that quiz to your last exam on Tuesday.
Oh, thank you.
If you want to bring homework questions,
Yeah.
let me get you them real quick here.
Oh, yeah.
Hold that thought, Charlie, just for a second, if you don't mind. So bring questions on the fundamental counting principle. It's the next homework assignment. Just bring questions on this for next time, just one page.
On Thursday.
Just for Thursday, right? And what this is a nice prep for the exam we'll do in class next week, in class.
Okay.
And the Powerballs we'll do in the out-of-class exam.
So this is prep for the in-class?
Yeah, essentially. Yep.
And the out of
Next Tuesday, yes, ma'am, next Tuesday. And it's already posted for you guys. Cool?
All right, later.
No, that's the notes. There weren't, basically, let me turn this off. Those are my little